Hi, in this lesson you're going to learn about template matching. A key takeaway from this lesson is to know that this technique exists and to become familiar with the concepts of the image pyramid, the stride size and the scale size.
Okay, let's have a brief look at a fourth technique called template matching. We'll just introduce this topic at this stage. We'll look at this template matching technique in more detail in the next module. Template matching is a technique for finding small parts of a digital image which match a template image. It's commonly used in manufacturing as part of quality control, as a way to navigate a mobile robot, or as a way to detect edges in images. As the animation in the following slide shows, conceptually, you create a template image, often a very simple template such as an edge or a line or a corner, and then you step that template image across the image of interest before scaling the image of interest, or the template if you prefer, and looking for the template again at a different scale. Usually you step the template across the image in a small amount of pixels, for example 4 or 8, to maximize your chances of locating the template in the main image. And usually you scale the image or the template a small amount each time, for example 2%, again to maximize your chances of finding the template in the image. Okay, in this example we have picked a very complicated template, but we're just illustrating the point. In a real example we might pick something a lot simpler. As we can see in the animation, the template, which is the yellow phone box in this case, is run over the image and a correlation score is obtained between the part of the image being analysed at each position and the template. The template is then, conceptually, moved across the image, obtaining correlation scores, and then down the image, again obtaining correlation scores. In this example, the image is then resized and the template is run across the image again. This process is repeated as long as you desire. You can run it until the image is the same size as the template, but usually it's better to terminate when the image feature being observed is too small to be of interest anymore. So the intuition here to take away is that you end up creating what's called an image pyramid. The part or parts of the image with the highest correlation score above a threshold are deemed to match the template. You usually get multiple matches of the same feature at different scales, and in a future module we'll work through an example where you'll see how to cope with this. The computation costs can become high, and the technique, while useful in carefully controlled environments, can suffer from occlusions of the object of interest in the image. That means that the object of interest, if you imagine a face, is occluded. Somebody else's face is in front of part of the face you're looking for. Also, rotations, reflections, and non-affine transformations, for example folding, are poorly dealt with by basic templating. And overcoming these leads towards a number of techniques involving either decomposing the template into, for example, edges, and searching for correlations between these sub-templates and the image and then summing, or adding more templates. For example, if you were searching for faces, you might have templates for side face profiles, full frontal faces, faces rotated maybe 15 degrees left, faces rotated 15 degrees right, and so on and so on. You would search for correlations for each template, running each template over the image pyramid separately. These techniques tend to be time-consuming to develop and need a high processing capability at runtime. There are many other extensions possible to the basic templating technique, using motion tracking and things like that to overcome occlusions, particularly if you're working with video. Okay, let's leave templating at that for now. We're going to come back to templates again in a later module where we'll do a bit more work on them.
Okay, after this lesson, you should feel you have an understanding of how you can use template matching. And you should also have a feel for where you can use it. As you'll see later in the course, the histogram of oriented gradients technique is derived from template matching.